Okay, so the last part of quadratics is another way to solve quadratic equations, and it's known as a quadratic formula. Quadratic formula. So I'm doing this out of my home because I'm quarantined for still a couple more days. So I had to put a board in my apartment, see how this works. If not, I'll read you these lessons. The quadratic formula is very straightforward. Now, we know the idea is how do we solve quadratics? So you're given this equation, ax squared plus bx plus c equals 0. And this was, this is how we solve quadratic equations. This is how we find the x-intercepts of parabolas. And so we had a couple of techniques. We could either use the technology and actually find the zeros. So we can write this as a parabola, stick it in the graphing calculator, and find the zeros. Or we've discussed techniques like factoring, okay? But another technique is something called the quadratic formula. Simply put is, you write the equation in standard form, ax squared plus bx plus c equals 0. You identify the a, b, and the c, and then there's a formula. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's just substitution. And I have a song that goes with it, and I'll sing it for you. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Very basic, very straightforward. Let's go through some examples. So the first example is x squared plus 5x. How about we make it, let's make it 9x plus 20 equals 0. Now, it's up to you at this point to decide what you want to do. If you absolutely know, you have your choices. You either plug this into the parabola and look for the zeros. You could factor. You might say, hey, Mr. Eller, I recognize the 5-4 combination. This is going to get me a 9. I'm going to do that on the side. You go, x plus 5, x plus 4 equals 0, x plus 5 equals 0, x plus 4 equals 0, x equals negative 5, x equals negative 4. That was the first method. Another method is just, putting this as a parabola, and you would notice that it would look something like this. And you go, oh, Mr. Ronald, my graphic calculator tells me this is negative 5 and this is negative 4. That could work also, or the quadratic formula. Identify the A, identify the B, identify the C, and plug it into the formula. You're getting this formula because IAB gives it to you, I'm giving it to you. X equals negative 9 plus or minus the square root of 9 squared minus 4 times 1 times 20 all over 2 times 1. You can either put this in your calculator or simplify it a little bit. Negative 9 plus or minus the square root of 81 minus 80 is 1 over 2. Well, this works out nicely. So we have x equals negative 9 plus 1 over 2, which is negative 4, or negative 9 minus 1 over 2, which is negative 5. And we see that these are the answers that we got either using our GDC or with our, factoring, either way. So what I just want you guys, so for standard, okay, so here's the deal. For standard 10, if you're taking applications, you're on the technology, you don't need to know this, and they're not going to be asking you a lot more. I'll put up the lesson that I gave for my standard level one, my 11th graders who are taking analysis. Now here's the thing. Here's what the quadratic formula tells us. This, once again, it's a great method for finding the solutions. If you don't want to factor, you don't want to use technology. Now, what they ask in analysis is they say, based on what can we tell about the nature of the roots? Okay? And so what we're going to see is, in the next video, is we can have different types of parabolas. Sometimes parabolas touch the x-axis. Sometimes the parabolas touch the x-axis in only one place. And in the third case, what we're going to see in the analysis video is that sometimes parabolas just don't even touch the x-axis. We saw this in all of our examples. Now the question is, how do we know if it touches in 2, 1, or 0? And what we do is we look at this expression under the radical. This expression, b squared minus 4ac, will tell us what the way our parabolas intersect with the x-axis. So, once again, you write your quadratic equal to 0, you identify the a, b, and c, and if b squared minus 4ac is greater than 0, then the parabola touches the x-axis, and it touches in 2 places, which means we have 2 real but different answers, 2 non-equal real roots. If the parabola just touches the parabola in one place, and I'm going to give you some examples, and you'll see it in the analysis video if you want to watch that. B squared minus 4 equals 0. There's 1 real root repeated. And then in this last case, which is outside of the scope of this class, if the parabola does not touch the x-axis, that could happen, then the discriminant is less than 0. There's no real roots. As I said before, this is way outside the scope of this class. And then you'll see in the analysis video, if you want to watch it. Once again, if you're taking applications, you don't need to worry about this, but the idea, I'll give you an example of an equation that just touches the axis. An example is x squared plus 6x plus 9 equals 0. Or what you can do is go to Desmos, and you can type in like x minus a squared equals, y equals x minus a squared. This will, any a value, the parabola will just touch the x-axis. So for example, I apologize. Here's a perfect example of a parabola that touches the axis in one place. In general, y equals x minus a squared. These parabolas touch it only in one place. And then in this example, how about y equals x squared plus 2x plus 8? That's an example of a parabola it's a parabola with a turning point, a y-intercept, and an axis of symmetry. It just does not touch the x-axis. And with this, you'll see that the number under the radical, the discriminant is negative. Okay. And I will upload the analysis video if you want to watch more specifics.